So let's talk about the graph of the functions. We're going to start with the easiest graph, which is the linear function. And you know that the graph of a linear function is just a straight line. And we can just simply use the y-intercept and the slope. So right here, the y-intercept is -6. To be exact, we have to say 0, -6. And then the slope is 3 over 1. So we go up 3 and then over to the right 1. You just need 2 points when we graph a linear function. So same thing over here, we have a +4 right here, and then we go down 3 to the right 4. As you can see, the graph decreasing because the slope is negative. All right, moving on to number 10. Hopefully you still remember the graph of an absolute values is like a V shape. Okay, so if you have the graph of, if you want to graph the absolute function, you can make table, but I don't want you to randomly pick points. So we're going to try to get the points, get the 0 first, which is the vertex. So you see right here, you want to get the vertex. So what is a vertex? In this case, the vertex is going to be, so if x equal to 6, you're going to get a 0, right? So 6 minus 6. So I want to get 0, so when I multiply by -3, I still get 0. So that's going to be your vertex, 6, 0. All right, so that's the vertex. Now, you want to go left and right of the vertex. So you see 6, we have 6, 0 here. Left would be 5 and right would be 7. So I'm going to pick those two numbers for the x values and evaluate for y. So we have 7. So 7 minus 6 is -1, and then you have time -3. So 7 minus 6 is +1. So +1 times -3 is -3. Now, if you go to the right, you go to the left, you get 5. Now, but if you have 5 minus 6 is a -1. Is when you take the absolute values, it's +1. So we get -3. You should get the same number, left and right. So 7, we get -3 right here. 5, -3 right here. So that's how we create the V shape. If you want to do one more, that's okay too. So like I said, you go left and right of the vertex. So left and right of the vertex would be 4 and 8. And those two should give you the same values. So 4, it's going to give you -6. And 8, going to give you -6. So we get the same values. As you can see, that is going down because of the negative right here. Okay, we're gonna do the same thing for the vertex, for a parabola. So we locate the vertex. Okay, I just want to remind you something. For the parabola, this is our standard form plus k. So hk is the vertex. Okay, so as you can see right here, the vertex is going to be 0, 0. So if you have 0, you plug it in, you're going to get 0 for y. Now, like I said, we're going to go left and right. So I'm going to go left and right, which is -1 and +1. So -1, you plug it in, you're going to get -2. +1, you plug it in, you're going to get -2. You should get the same y. There. Now, we can do one more pair, which is left and right of the vertex. So in this case, it's going to be -2 and +2. So once again, -2, I plug it in, I'm going to get -8. 2, I plug it in, I'm going to get -8. We should get the same number. All right, and there we have it, the parabola. All right, moving on to number 12. You see right here, it's in standard form. So the vertex is 5 and 2. Okay, so notice I'm going to go back to the standard form. So you see that the standard form, I have x minus h and positive k here. So h and k. So if you have a plus in here, then the h is going to be a negative. Okay, so keep that in mind. So if we go to this problem, you know the vertex is going to be 5, 2. Okay, so let's locate 5, 2. 5, 2 right here. All right, I'm going to go left, right of 5, 2, which is 4 and 6. So 4, let's plug it in. We have 4 minus 5 squared plus 2 is 3. 6. You should get the same number, 3. Okay, then you can do one more pair if you want. So let's do one more pair, which is 3 and 7. All right, so we are ready to plot. And then we have our parabola. All right, so for the graph of the square root function, hopefully you still remember it's going to be like that. Okay, so in this case, you can just simply plot the points. All right, so I'm just going to plot some points here. So how about we go with 1? Okay. Usually, if I have the square root function, I pick the perfect square, make it easy for me. So when you take square root of 4, you get 2. 2 minus 3 is -1. Okay. I'm going to pick 9. Because when I take the square root of 9, I'm going to get 3, and 3 minus 3 is 0. So 9, 0. And there we have it. So you can see that the cube root function looks similar to the cube function. So for this problem, I just plug it in, and like I said, for the square root, I pick the perfect square. For the cube root, I try to get the perfect cube. So when you take the cube root, it's going to be easy. It's going to be a whole number for you. Now let's take a look at odd and even function. So I just want to recall for even function, your graph is symmetric with respect to the y-axis. And then for the odd function, your graph is symmetric with respect to the origin. Okay, so since we have the graph here, you can see, so this is the absolute values function, but is neither even or odd. Now, for the next one, you can see that we have an even function because the graph is symmetric with respect to the y-axis. So if I take this one, I flip it over, I get this one. So that's going to be an even function. If you have the polynomial, it's really easy to spot even or odd because you just look at the exponents and the degree. So the degree in this case for g of x is an odd number, therefore it's an odd function. For h of x, the degree is even, then you have even function. If you have a combination of odd and even, that means we have neither. Okay. All right. So square root function, neither. This is a rational function, and as you can see, we have an odd exponent. So this is an odd function. Now, you see right here, we have an even. Okay. Now, I just want to remind you one more thing about even and odd. For even, when you plug in the equation, or when you plug in the function, you should get f of negative x equals to f of x. And for odd function, when you plug in negative x, you should get negative f of x. Okay, so you can always try. Okay, now transformation. So we want to translate the graph. Okay, so you can see that for part A, we have y equals to x squared. You want to translate to get the graph x squared plus 1. For if the number is outside of the parenthesis, that means we have up and down. Okay, so you can see right here we have plus 1. So all you have to do is take the graph and shift it upward one time. So we have the graph right here. So that's our graph. For part B, you see that is inside parenthesis here. Therefore, we go left or right. So if you have a plus, you go to the left. If you have negative in here, you go to the right. So because we have a plus here, so I know that my graph is going to go to the left 4 times. 4 units. And there we have it. So that's a transformation. All right, sometimes you're going to have to do both. So you can see for our next problem, we have a negative 3, which is down 3 unit, a negative 4, which is to the right 4 unit. So I have negative 3 and to the right 4.